Okay, let me share my screen. And here we go. All right. So I wanted to chat about BLAST, the basic local alignment search tool, and how we can use it from the command line, how we can download BLAST databases to blast against, or create our own out of a FASTA file. All of this is basically to compare sequences with each other, find the best matches, look at alignments, that kind of thing. Okay, so I'm in HPC, and I'm going to go to where all those Pando files are. We did last time. Let me pull this over here. Okay. So we've got the ITSX files. These have been extracted. And now if I look at one, I have to use zcat since it's gzipped. Zcat that file head. All right, so there we have it. We've got sequences. These are presumably the extracted ITS2 region without the flanking conserved stuff around there. And there's a few ways we could proceed. For this study, we're going to use a least common ancestor algorithm, but I want to show you BLAST. So if we take this sequence right here and blast it up against some database, I want it to return the best match so we can tell what this sequence came from. Okay, well, let me bring this over. If you go to ftp.ncbi.nlm.nih.gov BLAST, okay, this is the FTP site for the NCBI, and it's just got a bunch of files for downloading stuff. And so you can download different bio projects or samples that people have uploaded, the 1000 genomes projects, reference samples. I don't know what Osiris is. Who knows? Pathogen databases, but we can click here on BLAST and then look at DB. Here are the BLAST databases. Yeah. And so, yeah, we've got coronavirus. This BLAST database includes all of those files. Each one of them is a .tar.gz. That is a tarball. It's kind of like a standard zip where you have a bunch of files stuck together in one file. So we can extract that later. And then we've got an MD5, and this is a hash code that lets us whoops, it downloaded and opened here. That's it. This hash code with this file. The point of that is that we can compare that hash code with this file's hash code afterwards. We can run MD5 sum on it and see if it's exactly the same. A single byte changing during a download would change that entire hash code, and so we can use that to basically assure ourselves that things downloaded correctly with no corruption. So we've got all these MD5s that we can use to check after the fact, but essentially we just need all of these .tar.gz files if we were to download the beta coronavirus BLAST database. Now, one or two of you have asked about how to blast against, say, a custom database or like viruses, for example. So if I go on here, module load blast, then that gives me blastdb as a variable, and we can look at that. This is where the blast command will be looking for databases to blast against. So we can just give it the name. Let me go into that directory. Give it the name of any one of these databases, and it will be able to blast against it. And the way this works is I would say, like, blast my file against tsant, right? And so that would then know to look in this file because of the blastdb variable, and it would look for all the files that start with that and make sure that we've got, you know, this one's done in 3 parts. In each part, we've got all these index files that kind of work together. Okay, and so it'll be blasting against all of that essentially. If we just say tsant, swissprot, same way. Right? We would just say blast against swissprot. Well, this kind of limits us to the things that the admins have downloaded and stuck into the blastdb path. There's a lot of stuff here. But let's look for virusy things. Nothing. Right? And so they don't have the virus database, so we're going to need to download that ourselves. So we can search for virus on here. We don't want the coronavirus. Here's some hits. NT viruses. So that's viral nucleotides, NT. And then we've got the reference virus representative genomes. So we could download that and blast against all the reference viruses, or we could blast against all the viruses in NCBI as of a couple days ago. Okay. So I'm going to go with that one, just because, well, because I've already downloaded it preparing for this video. So let me get out of here. This is the blastdb directory that I'm in, that Blast already knows about, but we can make our own. So I've got a nice little storage directory found here. And it's got a bunch of data that's kind of for longer term stuff, but I've made databases. You could do the same thing in the scratch general vast your name directory that you've made. Things will eventually be deleted from there, but you got several months to work. And so you could make yourself a databases directory and then, oops, go in there. And you see that I've already made myself a little subdirectory called NT-virus. And I have downloaded and extracted all of that material. Let me show you what that looked like. It took a while to download and extract, so I'm not going to run you through the whole process. But where'd we go? Yeah. This. Just wget, essentially, for I in that nonsense. All right, let's pick that apart. That's our FTP site, the BLAST database. And then I'm basically saying all the files that start with NT-virus dot, and then I have a 0, 1, or 2, and then a 0 through 9 .tar.gz. If we look here, I hover down in the bottom right over here, you can see there's the file. It's got the URL /blast/db ntviruses.00.tar.gz. Well, that's just the file name there. And so I'm just going to put a for loop together that goes through this and picks out ntviruses.000102 whatever .tar.gz. And so we're just going to get all those files. So that's this for loop for I in all those possible combinations. Let me show you what it looks like. Copy that. Echo I done. There. There's all of my URLs that I'm going to be trying to download with wget. And so echo I, wget I, done. All right. Each one takes a minute or two to download. That's a lot. So let's not redo that process. But that gave us these files. So there, we've got them. Viruses 00 through 21. I had it trying to download 22 through 29 also, but I knew those didn't exist. It didn't matter. It just said file not found. Not a problem. Okay. So it went through and kind of brute force downloaded all of these. They are a .tar.gz, a gzipped tarball. They've been stuck together. Okay, well, the command I used to get them all extracted is another for loop for I in ntviruses star.tar.gz. So for each one of those files, echo the variable just for fun, and then here's the extraction. Tar, and then some flags. xzvf, and then the current name of the file in the for loop. xzvf, you can of course look these up on Google or say tar help, but X is for extract, Z is saying, hey, this is going to be gzipped, okay? V is verbose, so it'll like talk to us while it's doing it, and then F is the file. There's the file. Right. F has to be the last one since it's expecting this argument. The others can be out of order. So this is 90% of the time when I'm using tar, I'm either sticking files together or mostly I'm extracting other people's files. And so I've just got xzbf memorized and type it really quickly. But I think of it as somebody in a German accent saying, extract the file. Yeah, I know. But that's how I remember it. There's the file. Okay, so I'm extracting them. And when I did each one of those, so here's 20, was turned into these 6 files. Those are the blast index files. Head 1 of that, we got some stuff. Head 2, it's not really meant to be human readable. There's a lot of gobbledygook in there, but it's got some information for us. But these are really binary files. They're not meant to be read. Okay. So, woo. They're not for you. They're for the BLAST program. So, the way BLAST works is if we're blasting nucleotides, that's blastn. Proteins would be blastp. But we've got nucleotides here. And essentially, we're not going to find much. If I go back to storage dir, cd storage dir, pando to data clean. So let's say I wanted to take this file. It's gzipped, so I have to use zcat if I want to look at it. All right, here we go. This file, we've got a bunch of sequences in here, and we want to blast them against our new virus database that we downloaded. Maybe we'll find stuff. These are supposed to be fungal reads, so I really doubt it, but I'll show you how. Okay. There's our file. It's in fastq.gz format. BLAST does not like that. It likes a FASTA format, and it doesn't like it to be compressed in a gzip. But like this, blastn, here's my query. Okay. Here's my database. Here's the output format that I want. This all just comes from the help file. I want format 6, which is tab separated. The query sequence ID, the subject sequence ID, the e-value, the expected errors, percent identity, the kingdom, the scientific name of the best hit or hits, the common name, the blast name, and the title. And then I'm saying, just give me the top hit, and then write some output and the number of threads. There's a lot of different formats, so you could return the actual sequence alignment. If you say blast help, blast and help, you get a whole bunch of stuff and a lot of different ways that you can kind of customize how this works. But essentially, this is it. BLASTn, and then give it some stuff and tell it, here's the sequences I want to search for. Here's the sequences I want to search against, or the proteins, right? And then here's how I want you to handle finding the best hits. So you can change all the parameters there. And here's how I want it to be put out. Right? And so here's that formatting. I was just saying, hey, I want 6. And then it says, oh yeah, if you pick any of these 4 options, you can configure what do you want in there. So here's all the different things I can have output. And so I've just picked a few right there. Okay, so let's see this in practice. I could search this file. BLASTn query is that file. We'll have to change this because remember, it doesn't like fastq, it doesn't like gzipped. The database is, I could just say nt right there, and that would look in the blastdb directory and find the nucleotide files and search it against that. Or I could send it to my custom database. All right, and so here I'm defining that. Custom DB equals, and then this is where I downloaded and extracted those files. This is the directory. So if I list that directory, I see all my viruses. And then I want to give it the base name of the file, nt viruses. And so that's that right there. So I could say custom DB is that. And so now when I'm writing my blast command, blastn query, oh crap, I forgot. BLASTn, the query, the sequences I don't know. The DB, I'll say take it to $custom DB, so it'll know where to look and the name of the database. Okay. And then output format, I'm going to paste that in. And then the max target sequences, just to speed this up, saying just return the top hit. and then the out. Okay, so my custom DB, I had this written for a for loop previously. I'm just going to tell it, there's my query. Oops. Ah, man, I hit Control C instead of Control Shift C. All right. Copy. So ITSX. So my output file, be that dot blast out or whatever. Okay. We can do this in a for loop as well. We're just doing it for one right now to get a feel. So blasting, there's my query, there's my custom database, here's the big old string for my output format. Return just one target sequence from the query, and then the output, there's the name of the output file, and then I can say num threads, whatever, but I'm going to try this on the login node because I'm crazy. But first off, it's not going to work with that as a query. It really wants a FASTA format and not gzipped. So I'm going to come back up here, and it wants a file. So instead of a dollar parentheses, I use the fake file, process substitution, zcat that, pipe it to seek tk, seek, I already did module load seek tk, a to force FASTA output, and then I'll say head for just to speed this up. So it won't do the whole file, just the first two sequences in there, right? Because it's every other. So let's see. This fake file will be our query. That pipe to seek tk a, just the first 4 lines, so the first 2 reads. Hopefully this doesn't get kicked off of the login node, and I'm gonna hit it. Okay. So it's giving me a warning. Hey, you should probably examine more than just one match. Yeah, I know. It's looking against that whole database. I think I'm going to say num threads 12. I happen to know that I can do that on the login node sometimes if it doesn't destroy everything and get me kicked off. This is taking longer than I expected. Blast is a really pretty slow program. It's great. It's still in widespread use because it's really, really nice. It's a good algorithm, but it does take a long time to run sometimes. I'm already bored with this. Should have made this a Slurm script. So I'll cancel it and look for anything blast out. Okay, so there it is. There's nothing in there right now because it was still like in the process of searching against that whole new virus thing that we've downloaded. Okay, but that will be the output file essentially, and it will be in the format that I specified, tab separated. It'll have the query ID, so that FASTA header for my file, and then the best hit sequence ID, how good of a hit it was, and then what that sequence, what organism it's from, hopefully. Okay. And so that's blasting against a local database. It's really not too hard. It's pretty customizable. It does take a long time to run, and so I would turn this into a Slurm job, right? And for my purposes, I don't want to do it with NT viruses because I'm looking for fungi. So I'm actually going to make a custom fungal database. And I have not done this yet because I use a different algorithm typically to assign taxonomy to unknown sequences, but we could do it with BLAST. And so I know they don't have this, the eukaryote, so I'm just going to download this FASTA file of the eukaryotic ITS. We've got 1.4 million sequences. Okay, that's not so big. So I'm going to take that, copy link, and then what do you think? Storage there, databases. I'm going to make eukaryote. And just the BLAST directory. So here I am in a nice place, and I'm going to wget that file. It's not too big. It's a zipped file, so we're going to unzip it with, you guessed it, the unzip command. But that should be here any minute now. And then what we're going to do is make a BLAST database. So like all those .nts and .nob files, that's a BLAST database. They were made from a FASTA. And so we can actually make a BLAST database. You give it some input. You tell it whether it's nucleotide or protein, and you give it the base name of an output. And that's it. Okay, so unzip that. It's just a giant FASTA file. We'll take a quick look at it. There we go. Ta-da. 1.5 gigs. Okay, this might take a little bit, but that's all right. Since I've got module load, the BLAST module loaded, I can say make BLAST DB. My input is that FASTA file. Type, DB type. Let's copy this. DB type is NuCl for nucleotide. The help file will show you this. And the output, eukaryote 1.9.3. I'll do underscores. That's it. So that's building a new database with all those separate little files. It'll number them 1 through whatever, depending on the maximum file size here. So we're just like splitting it up into a bunch of smaller bits. That speeds things up downstream. And who knows how long that'll take. But that makes a new BLAST database. So you can BLAST any set of files against any custom database that you make. All you need is a FASTA. And in the headers of those FASTA files, that's what's going to be kind of your like best hit. Hey, that wasn't so bad. There they are. So now eukaryote 193 is my BLAST DB. And it's here. Eukaryote 193. So that's my custom BLAST database. Copy that. I can paste that in here. All right, so now I can turn this into a for loop. I could say BLAST, here's my query, right? In a for loop, let's see, what would this look like? For I in star dot fastq.gz. Well, what are my file names that I'm dealing with? Ando data clean. Okay, so 001 itsx.fastq.gz. Copy that. For I in star that. Do, just for fun, echo I helps with debugging sometimes. I like to see the progress bar. And then query equals I, sure. I could have just said for query in that, but yeah, why not? For query in all of those, echo my query. blastn, that's not going to quite be my query though, is it? Oh. Query equals what? I think what I'm going to do is say zcat I, pipe it to seek tk seek, and send it to something called query, a file. So I'm making myself a little FASTA file within the for loop. And then that file will actually be named query, so I don't need a value there. It's not a variable. I'm using my variable here to generate a real file called query. And that file will be my query. My database will be my custom eukaryote database. I want that same output format. And then I do want to use I to make a reasonably named output file. So out is I, where I replace fastq.gz, oops, copy, with blast.out. Number of threads will be 64 and done. Okay, so this should take care of it. It'll blast one at a time all those files against my new custom database in its little custom database location. I hope it's happy there. And it's going to return a tab separated file called whatever the file name was, .blast.out. And it's going to do it with 64 threads. Done. So I'm going to go ahead and why not submit this. That's really all of it. I already got the stuff downloaded. I've made the BLAST database. And so scripts nano blast eukaryote.slurm. Okay, save that. We'll come in here and copy my little slurm header because I'm lazy. Okay, I am going to ask for 3 full days. I'm going to change the slurm output and error stream files to slurm blast job number.out.node number 64. ITS blast. Okay, so then I say module load seek tk and blast. You can do it all in one line like that. Load modules. Define variables. So there's my custom database. I need to tell this where everything is though. So I'm going to save that, exit. Here's where I am currently, but where are the files? They're in data clean. All right, so copy that. Yep, that's where I want to be. That's where all my query files are. So I'm going back into scripts, open this back up, and I'm going to say my directory for the files is that. And I'm going to go there. So I define that variable, I go there, and then inside of there, I'm saying for all the itsx.fastq.gz files you find, echo that, make a new file called query, run blast against my custom database, and I think I'm going to remove query each time through the loop so we don't have that file kind of cluttering things up. Won't matter, I could remove it outside the loop at the end. It's fine. It only takes a split second to remove it. Let me think if I'm forgetting anything. That should work. S batch blast eukaryote dot slurm. Track jobs is an alias I set up, and it's just that S account, but I've told it format, just a format I like. So I could say S account also, and look, there it is. It's running. When I say track jobs, it's just a little bit prettier for me, and I can see how long everything's been going. Okay, well, it's been running for a few seconds now. Go up into data clean where I was working. There's query already. All right, so that's a beautiful little FASTA file. We got some short dumpy sequences, but the blast output will have our eukaryote headers. It'll say like, hey, here's the sequence that we are querying. Here's the best match in the database. Here's how well it matched, and here's its name. It might not even tell us its name because I didn't do any taxonomy parsing, but we've got our query, and there we have blast out popping up. Ooh, one of them's already returned some stuff. Let's look at that. Oh dear. Okay. My query, the ID of the best hit, and then the information about it. So it's a plant, tracheophyte, angiosperm, populus. Cool. Well, this was from Pando, and so looks like we've got some Pando DNA. And then our next search was also more of Pando. Fun. So this is good to know. These are sequences that we'll need to throw out later, but it does seem to be working. And we're getting like really nice matches. Blast works again. LL star blast dot out. So we've already got a bunch of files because we're running 64 threads. We're doing this 64 times simultaneously. So each file gets its kind of own process. And we're getting results. That's not taking too long at all. Cool. I mean, at this rate, it might be done in an hour. I asked her 3 days, whatever. But there you have it, blasting against a local database.